Okay, let's just dive right in. August 3rd. It might seem like just another random day on the calendar, but it's actually one of the greatest, most serendipitous dates in all of mathematical history. Welcome to the Explainer, folks. Today, we're going to see exactly why this specific date literally built the modern technologies sitting in your pocket right now. It's a massive story about hidden patterns, so let's get into how it all connects. We've got a pretty wild timeline to cover, jumping from 1835 all the way up to 2016. On this one magical date, across entirely different centuries and continents, four totally different brilliant minds all ended up asking the exact same kinds of questions. Now, these mathematicians didn't know each other, obviously, but they unlocked the very secrets we rely on every single day. Let's meet them one by one. We're going to kick off this detective story with a question about something we all use constantly. Have you ever actually stopped to wonder how your smartphone apps instantly calculate your average daily screen time? Or how they predict the exact odds of it raining this afternoon with such crazy accuracy? Well, to find that answer, we actually have to rewind all the way back to August 3rd, 1835. We're talking way before smartphones, the internet, or even widespread electricity, to meet a guy named Artemas Martin. Now, Martin was not your typical stuffy academic. He was this incredible, completely self-taught mathematical genius. No advanced formal schooling whatsoever, but he was solving absolutely mind-bending problems based on average distances and probabilities. Imagine trying to figure out the exact average distance between any two random points in a circle without a textbook to guide you. That's what Martin was doing for fun. He basically showed us how to calculate the odds of totally random, unpredictable things happening. And guys, that is the exact foundational math our modern apps use today. When your weather app crunches massive amounts of chaotic data to give you a reliable prediction, it is running straight on the probability groundwork that Martin laid out. It perfectly illustrates our first big takeaway here. Every prediction app we use is built on the hidden math of averages and odds. It's literally just the chaos of the real world, totally tamed by math. Okay, still on August 3rd, but let's jump forward a bit to the year 1917, where a completely different mathematical mystery pops up. Before we get into the math on this one, think about the stakes here. How exactly does your banking app keep your password completely secure from hackers? How do these digital systems lock away our most sensitive secrets using hidden patterns that even supercomputers can't easily crack? The mastermind who unknowingly laid the groundwork for this giant digital fortress was Georg Frobenius, a total genius who we remember on this exact day, August 3rd in 1917. So Frobenius founded this thing called the machinery of representation theory. Basically, it's a brilliant way to decode the complex structures of group symmetries. I know, that sounds like a bunch of heavy academic jargon, but let's break it down. Imagine trying to describe the perfectly symmetrical, complex shape of a beautiful snowflake to someone, but you are only allowed to use numbers to do it. That's representation theory. Frobenius figured out how to map physical, structural symmetries into pure abstract math. He decoded how patterns shift and alternate without ever losing their core structure. Fast forward to right now, and that exact foundation is what our computers use to scramble, encrypt, and secure our private data. The data gets shifted into these super complex symmetries that hackers just can't reverse without the key. The crucial point here is kind of beautiful when you think about it. The absolute highest levels of digital security are, at their core, just complex mathematical symmetries in disguise. Beautiful geometry is literally guarding your bank account. All right, same date, 26 years later. Now we're in 1943, in a totally different country, tackling an even bigger idea. Think about billions of phones and computers connected all over the globe, firing off massive amounts of data every single second. Have you ever wondered how the internet knows exactly how to route a WhatsApp message to your best friend in mere milliseconds? How does your text never get lost in that giant chaotic web? The blueprint for that specific modern miracle was born on August 3rd, 1943, by an absolute legend of a mathematician named Béla Bollobás. Bollobás is a world leader in something called extremal graph theory. Essentially, he mapped out the invisible structure of random networks. Think of extremal graph theory like this giant invisible map made of billions of random dots, where each dot is a computer. Bollobás figured out the absolute maximum and minimum connections you'd need to guarantee a clear path between any two random dots on that giant map. He wrote the definitive rules for how incredibly complex, sprawling connections behave in a network. And that right there is the exact mathematical blueprint our global internet uses today.
When you hit send on a photo, routers use his math to instantly find the absolute fastest, most efficient path between your device and your friend's device, cutting right through all the noise.
What's so wild about this is the intimacy of that massive scale, you know? Every single social media connection you make, every quick text you send, is literally a tiny line in a massive global mathematical graph. It's crazy, right? One date, so many incredible stories. Let's keep the momentum going and jump straight into the modern era, 2016. When we look at stunning, hyper-realistic graphics on our screens, how does a computer actually build those virtual worlds? Have you ever noticed how the ultra-realistic fire-breathing dragon in your favorite 3D video game is actually just a massive geometric puzzle made of thousands of tiny, flat, interlocking shapes? The genius who really helped us make sense of these digital puzzles was Geoffrey Shephard, who passed away on, yeah, you guessed it, August 3rd, 2016. Geoffrey Shephard literally dedicated his life to studying geometric tilings. He was an absolute master of visual geometry in complex shapes. Basically, he studied the math of how shapes fit perfectly together without leaving any empty gaps between them. He showed us exactly how symmetrical solids can perfectly fill a three-dimensional space, crunching the complex angles and edges required to make a totally smooth surface out of flat tiles. And this isn't just abstract theory, guys. This provides the very mathematical rules that modern computer graphics engines use today. Every polygon mesh that builds the characters, the epic landscapes, and the virtual worlds we love to explore, they rely directly on the geometry of tilings that Shephard helped decode. And this leads us to such a cool aha moment. The stunning 3D graphics on your screen right now are just brilliant geometric tilings seamlessly filling the digital space. Let's just take a step back and review what we've uncovered today. From Artemas Martin's early probability calculations that completely power our modern prediction algorithms, to Georg Frobenius' work on symmetries giving us impenetrable digital security. Then you've got Béla mapping out random networks for lightning-fast internet routing. And finally, Geoffrey Shephard's geometric tilings building our 3D graphics. Every single person we met in this explainer, across different centuries, different countries, all fundamentally ask the exact same question. What is the mathematical pattern hiding inside the chaos? And because they asked that, our world today is forever transformed. These guys didn't just study numbers on a chalkboard. They literally unlocked the future we live in. So I want to leave you with this final provocative thought. If these four brilliant minds built our entire modern world just by looking for patterns, what mathematical pattern will you discover next?